Hello everyone and welcome to Amazon Sagemaker Ultimate course. In this video we're going to go over a summary of what we're going to be learning throughout the course. So in section 2 we're going to talk about how to create an AWS account and set up the account. In section 3 we're going to talk about Amazon Sagemaker, so we'll cover Sagemaker Studio, Dashboard, Search, and Images. In section 4 we're going to talk about ground truth, so labeling jobs, labeling data sets, and labeling workforces. Then we're going to talk about notebooks, so notebook instances, lifecycle configurations, and Git repositories. In section 6, we're going to talk about processing, so processing jobs. In section 7, we're going to talk about training, so algorithms, training jobs, hyperparameter tuning jobs. In section 8, we're going to talk about interface, so compilation jobs, model packages, models, endpoint configurations, endpoints, and batch transform jobs. In section 9, edge manager, so get started, edge packaging jobs, edge device fleets, and then edge devices. In section 10, we're going to talk about Augmented AI, human review workflows, worker test templates, human review workforces. Section 11, we'll talk about AWS Marketplace, so model packages, algorithms, AWS data exchange, and all products. Then section 12 will conclude the course with a conclusion and go over a summary of what we learned throughout the course. So that in mind, thanks for watching. I'll see you inside the course. All right, let's create an AWS account. Okay, so let's go over to create an AWS account. And what it's going to ask for is an email address, a password, to confirm the password, and then an AWS account name. Now, I'm going to give you a full disclosure here. I've already created an account, so I'm not going to go through all the steps, but I will walk you through what you need to do, okay? So from email address, I'm just going to type in one of my random email addresses. I will do a password, I will do another password, and then we'll just do sample. Okay, I'll continue. So they need to verify that I'm a real person. So we're going to do, for mine it's F66M6S. I'm going to continue. Okay, then they're going to ask for contact information. How to use your plan, business or personal. Who should we contact about this account? So put your full name, your phone number, your address, city, state, postcode, okay, and then continue on. Okay, so I'm going to pause the video. I'll put all that information in, then I'm going to continue to the next step. Okay. All right, welcome back. So with this, I'm using my Finder here as kind of a way to censor my sensitive information. So what you're going to do is you're going to put in your credit card information, expiration date, the year, and then the card holder's name. Down here, it's going to show your address, okay? And then right here, you're going to verify and continue to step. This is step 3 of 5. So then you would continue on to the next step and then follow and set up the information that they need, so on and so forth. Okay, so that's how you set up an account. Thanks for watching. I'll see you in the next video. All right, welcome back. So in this video, we're going to talk about Sagemaker Studio. So how to get started. Quick start. Let Amazon Sagemaker handle configuring account, and setting permissions that you and your team in your organization need to use Sagemaker Studio. Choosing this option uses standard encryption, which you cannot change. If you need more control over configuration, choose standard setup. Okay, so we can do standard setup, and then we can go through the information that we need for Sagemaker Studio. Now, we're not going to complete this. We're just going to kind of skim over what they have here. And like I said, I'm going to go into a deeper deeper information on Sagemaker. Okay? So with that, I'll leave you there. Thanks for watching. I'll see you in the next video. All right, welcome back. So in this video, we're going to talk about dashboard. So in the dashboard, you can prepare, build, train and tune, and deploy and manage. So we can open Studio, we can do data wrangler, processing, feature store, clarity, clarify, build Studio notebooks, built in, and bring your own algorithms, autopilot, jumpstart, train and tune, one-click training, experiments, automatic model tuning, debugger, manage spot training, deploy and manage, one-click deployment, multi-model endpoints, model monitor, pipelines, and post-processing job. Then we have a console, so ground truth, AWS Marketplace, Interference, and Sagemaker Edge Manager. Okay. Then you can see your recent activity. And that, in a nutshell, is the dashboard. So, thank you so much for watching. I will see you in the next video. All right, welcome back. So in this video, we can search for training jobs. To view results, enter search property and choose search. So we can just grab something random here. Let's just we'll do search. Okay, let's do a search, see if anything pops up. Nope. Okay, no problem. So that is search. Thanks for watching. I'll see you in the next video. All right, welcome back. So in this video, we're going to talk about images. So you can see we have name, display name, created, status, and actions. We can click on create an image. This is going to we can enter an ERC or ECR image URI, enter a registry path to an image in Amazon ECR in the same region as studio domain. Okay, and then we can look at the image properties. So image name, image display name, description, IAM role. Amazon SageMaker requires permissions to execute this image on your behalf. Choose a role or let AWS create a role that has Amazon SageMaker full access IAM policy attached. Okay, and then you can add a new tag. So we'll hit cancel, and that is custom images. So thanks for watching. I'll see you in the next video. All right, welcome back. In this video, we're going to talk about ground truth and labeling jobs. So if I click on create labeling job, I can go through and I can label. We can do a maximum of 63 alphanumeric characters. Okay, can include hyphens but no spaces. Must be unique with your account in AWS region. We can do automated data setup or manual. We can go through here and do S3 location and input data sets, S3 locations for output data sets, data type, and then IAM role, complete data setup, and then you can see here there's different categories. So we can do image classification, single label, multi-label, bounding box, semantic segmentation, label verification. Okay. You can also do video. So there's video here. So there's a whole bunch of stuff you can do with this. Okay. So that's labeling jobs. Alrighty, so thanks for watching. I'll see you in the next video. All right, welcome back. So in this video, we're going to talk about data sets and how you can label them. So this is where you would label them if you had any. The input and output data sets of labeling job will be listed here. So if you have any labels, this is where it would be. All right, so thanks for watching. I'll see you in the next video. All right, welcome back. So in this video, we're going to talk about labeling workforces. Okay, so you have Amazon Mechanical Turk, a team of global on-demand workers powered by Amazon Mechanical Turk. This is the summary right here. You have labeling jobs, so name, status, task type, labeled objects, total, creation time. There are currently no labeling jobs created for this team. You can do private, create a private team here, a team of workers from your organization, and then a vendor. Find data labeling services for your vendor, and you can do it all right here. So thanks for watching. I'll see you in the next video. Alrighty, welcome back. So in this video, we're going to talk about Notebook. So let's go ahead and click on Notebook and go to Notebook Instances. You can see here there are currently no resources, but if we click on Create New Notebook Instant, okay, Amazon SageMaker provides pre-built, fully managed notebook instances that run Jupyter notebooks. The notebook instances include example code for common model training and hosting exercises. Okay, notebook instance settings. Okay, you can do whatever kind of instant type you need here. Okay, so standard, you have compute optimized, memory optimized, accelerated computing. Then we have elastic interface, platform identifier, additional configuration. Then you have permissions and encryption, network, Git repositories, and tags. So I'm going to cancel out of that. That's how you work with notebook instances. All right, so thanks for watching. I'll see you in the next video. All right, welcome back. So in this video, we're going to talk about lifecycle configurations. So let's go and click on Create Configuration and talk about this. So you can put a name in here, okay? And what you can do is give it a name, numeric characters, and a dash but no spaces, maximum 63 characters. Start a notebook. Okay, so you can write a notebook here. And then we can create a notebook here and create a configuration. I don't know why that was doing that. So I apologize for that. I'm going to cancel out of this. So that's how you can do a lifecycle configuration. Thanks for watching. I'll see you in the next video. All right, welcome back. So in this video, we're going to talk about Git repositories. One of my favorite topics to talk about. So we can add a repository. And so here's the thing. Let's go ahead and click on it, and then I'll do a deep dive into this. So you can see here what type of repository do you want to add. So AWS code commit, highly available Git source control from AWS, includes encryption, IAM integration, and more. Or you can do GitHub or other Git-based repos. Connect GitHub or other Git-based repository, store credentials with AWS Secrets Manager. So you have Amazon SageMaker repository name, Git repository URL, repository branch name, which is optional, and then Git credentials. So what is the point of Git? Okay, people get this confused sometimes. Git is basically version control. Okay, so the idea behind programming or software development or app development is it's constantly changing, right? It doesn't stay the same. So how do you have it constantly change? How do you manage that? Git repositories. Basically, it's cloud-based storage for your code. Okay? Now, the way that it was used to be done, which I still do it this way myself, but a lot of people would have a local server on their computer where they could work offline. Okay? So you could build and develop your website offline and then bring it online when it was done. Okay? Or you could bring it online for testing. But for the most part, you would keep it offline. Now, with GitHub, you're always connected, but you can always get access to the code. All you need to do is pull down the repository. Okay? So when changes are made, you can see when those changes are made. They're highlighted. And also what happens is you can go back to a previous edit. So you have resources so you can recover what you need to on your project if something were to happen. And the good thing about putting it on the cloud over having it on your computer is, what if your hard drive crashes, okay? Compared to if you have it on GitHub, they have backup upon backup upon backup of your stuff, okay? They're not running a business where they're going to have everything on one hard drive. That's simply not going to happen. So GitHub, Git repositories are very important. So with that, thanks for watching. I'll see you in the next video. All right, let's talk about processing jobs. So let's create a processing job. When you create a processing job, Amazon SageMaker sets up the distributed compute cluster, executes the computation, and deletes the cluster when processing has completed. The results are stored in the location you specified when you created the processing job. So you can set all those parameters right now so that they end up where you want them to be. So there's no real mystery. You know exactly where they are. Okay, so that's the significance of doing it this way. So what you would do is you'd set the job name, the container, the IAM role, and then resource configuration, so the instant type, the count, the additional storage, encryption key is optional, stopping condition, network, enable network isolation, or VPC, which is optional, app specification, which is optional, input data configuration, output data configuration, and then tags. Okay, so that's how you can set up a processing job. So with that, thanks for watching. I'll see you in the next video. All right, welcome back. So in this video, we're going to talk about training and cover algorithms. So we're going to talk about how to find an algorithm, how to create an algorithm. So let's first create an algorithm. Okay, so we can give it a name, a description, training specification, and then we can do channel specification, okay? Channel name, description, supported input modes, supported content types, and then supported compression types, okay? So that's how you get working with the algorithms. We can also look at the AWS Marketplace subscription, so we can find algorithms. You can find and subscribe to algorithms from the AWS Marketplace. Okay, so there you go. So thank you so much for watching. I will see you in the next video. All right, welcome back. So we're going to talk about training jobs. So let's create a training job. Okay, so when you create a training job, Amazon SageMaker sets up the distributed compute cluster, performs the training, and deletes the cluster when the training is completed. The resulting model artifacts are stored in the location specified when you created the training job. Okay, so thanks for watching. I'll see you in the next video. All right, welcome back. So we're going to talk about hyperparameter tuning jobs. All right, so let's go ahead and let's take a look at that. Let's create a hyperparameter tuning job, go through the steps to create one. You basically define the job settings, create the training job definition, configure the algorithm and the parameters, define data input and output, configure resources, configure tuning job resources, and then review and create. And so that's how you go ahead and create the hyperparameter tuning jobs. All right, so thanks for watching. I'll see you in the next video. All right, welcome back. So in this video, we're going to talk about compilation jobs. So if I click on create compilation job, I can go ahead and I can set up the job settings and everything else that we need in order to be successful with the setting up the compilation job. Okay. So what we can do is we can give it a job name, an IAM role, input configuration, so the location of the model artifacts, data input and configuration, and machine learning framework. Then you have output configuration, network, which is optional, and then tags. Okay, so thanks for watching. I will see you in the next video. All right, welcome back. So in this video, we're going to talk about model packages. So model packages, let's create one. If I go to create, we are going to do interference specification and then validation specification. So the model package name and description. We're going to do model package name. We'll do description, which is optional. And then inference specification options, container definition, supported resources, and then we have supported instances types for real-time interference, supported instance type for batch transform jobs, supported content types, and supported response MIME types. All right. So with that, that is model packages. Thanks for watching. I will see you in the next video. All right, welcome back. So in this video, we're going to talk about models. Okay, so models. Let's create a model. So I click on Create Model. To deploy a model to Amazon SageMaker, first create the model by providing the location of the model artifacts and interference code. So you set up the model name, IAM role, container definition. So we're going to do container input options. Okay, provide model artifacts and interference image options. Okay, environment variables, and so much more. All right. So, with that, thanks for watching. I will see you in the next video. All right, welcome back. So in this video, we're going to talk about endpoint configurations. All right. So if I click on Create Endpoint Configurations, we are going to talk about to deploy models to Amazon SageMaker, first create an endpoint configuration. In the configuration, specify which models to deploy. The relative traffic weighting and hardware requirements for each. Okay? Endpoint configuration, async of invocation config, data capture, production variants, and tags. So, there you go. Thanks for watching. I will see you in the next video. All right, welcome back. So in this video, we're going to talk about endpoints. So if I click on Create an Endpoint, to deploy models to Amazon SageMaker, first create an endpoint, provide an endpoint configuration to specify which models to deploy and the hardware requirements for each. So you're going to give it an endpoint name. We're going to attach the endpoint configuration, use an existing endpoint configuration or create a new one, and then you fill out all the information here, and then you can create an endpoint. Okay? So with that, thanks for watching. I'll see you in the next video. All right, welcome back. So in this video, we're going to talk about batch transform jobs. So let's click on create batch transform job. And you can see here the job name, the model name, the instant name, the encryption key, input data configuration, output data configuration. Then you can optionally do input, output filtering, and data joins, environment, variables, optional, and then tags, optional. Okay, so with that, thank you so much for watching. I will see you in the next video. All right, welcome back. So in this video, we're going to talk about how to get started with Sagemaker Edge Manager. So train your machine learning model, keep track of model name and its S3 bucket URI. Okay, compile your machine learning model with Sagemaker Neo, create 2 Amazon S3 bucket URIs, create security policies for your S3 bucket URIs with IAM role that gives Sagemaker secure access to your data. Download the Sagemaker Edge Manager agent for your device type. Okay, so that's how you get started with the Edge Maker. So thanks for watching. I will see you in the next video. All right, welcome back. So in this video, we're going to talk about edge packaging job. So let's create an edge packaging job. So create an edge packaging job to make models compiled with Sagemaker Neo compatible with Sagemaker Edge Manager. You can deploy your model to your devices once the packaging job is complete. Okay? So you give it a job name, a model version, IAM role, resource key, ARN, edge packaging job tags, which is optional. Then you would go to the model source, okay? And then the output configuration. And then you would submit and you would have a edge packaging job. So with that, thanks for watching and I will see you in the next video. All right, welcome back. So in this video, we're going to talk about edge device fleets. Okay, and what exactly is that? Okay, that's really, so let's create a device fleet. So use the fields below to enter the name and role for AWS lot to use. You can optionally add a device fleet description and a device fleet tag. Okay, so you would enter all your information in here, go to next, and then do output configuration, and you're good to go. All right, so thanks for watching. I'll see you in the next video. All right, welcome back. So in this video, we're going to talk about edge devices. So with that, let's take a look at how to register devices. So what you would do is you must register your devices with a fleet to use Sagemaker Edge Manager, okay? So you would enter in the device fleet name and then the device source here, and then you can add it. And we can add up to 50 devices, okay? So there you go. Thanks for watching. I'll see you in the next video. All right, welcome back. So in this video, we're going to talk about human review workflows. So let's take a look. So Amazon A2I provides built-in human review workflows for common machine learning use cases such as content moderation and text extraction from documents, which enables you to review predictions from Amazon's recognition and Amazon text track. You can also create your own human review workflows for machine learning models built using Amazon SageMaker on other tools. So we can create a human review workflow here, go through and put your information in there, and you can select a text track, a custom, recognition, image moderation, okay? Get human review of unsafe content such as explicit adult content or violent content. Okay, so it will let you know if it's safe or inappropriate. You can do worker types, Amazon, Mechanical Turk, private, and then vendor. And that is the human review workflow. So thanks for watching. I will see you in the next video. All right, welcome back. So in this video, we're going to talk about worker task templates. So let's take a look. So if I click on create a template, create a custom worker task template and integrate it with Amazon Augmented AI human review workflow. Flow definition. To customize the worker task user interface and instructions. Okay, so we can give it a template name, template type, and then we can do the template editor and write in our code here and get it set up to what we want. So that's how you create a template. All right, so thanks for watching. I will see you in the next video. All right, welcome back. So in this video, we're going to talk about human review workforces. So what you can do is a team of global on-demand workers powered by Amazon Mechanical Turk. So you have private, you can create a private workforce and share it between ground truth labeling jobs and augmented AI human review services. And then vendor, you can find a human review service. So there you go. Thanks for watching. I'll see you in the next video. All right, welcome back. So in this video, we're going to talk briefly about model packages. So need help creating a custom machine learning solution? Connect with AWS IQ Expert to train a custom model in Amazon Sagemaker. So the featured model packages are here. So you can grab one of these and utilize these for whatever you need. Okay, so thanks for watching. I'll see you in the next video. All right, welcome back. So in this video, we're going to talk about algorithms that you can obtain from the marketplace. So you can go through here and pick out one that you need for your project and you're good to go. Thanks for watching. I'll see you in the next video. Hello everyone and welcome to the summary of Amazon SageMaker Ultimate Course. In this video, we're going to go over a summary of what we learned throughout the course. So in section 2, we talked about how to create an AWS account and set up an account. In section 3, we talked about Amazon SageMaker and we covered SageMaker Studio. We talked about dashboard, search, and images. In section 4, we talked about ground truth, so labeling jobs, labeling data sets, and labeling workforces. In section 5, we talked about notebook, so notebook instances, lifecycle configurations, and Git repositories. In section 6, we talked about processing jobs. In section 7, we talked about training, so algorithms, training jobs, and hyperparameter tuning jobs. In section 8, we talked about interface, so compilation, jobs, model packages, models, endpoint configurations, endpoints, and then batch transform jobs. In section 9, we're going to talk about edge managers, so get started, edge packaging jobs, edge device fleets, and then edge devices. In section 10, we talked about augmented AI, so human review workflows, worker task templates, and human review workforces. In section 11, we talked about AWS Marketplace, so model packages, algorithms, AWS data exchanges, and all products. So with that, I want to congratulate you on finishing Amazon SageMaker Ultimate Course. If you have any questions or concerns about the course, please let me know. I'll be happy to help you in any way that I can. Until next time, take care and thanks for watching. Hello everyone and welcome to Amazon SageMaker. In this video, we're going to go over course overview and what we're going to be learning throughout the course. So in section 2, we're going to talk about Amazon SageMaker. We'll talk about what is Amazon SageMaker, machine learning with SageMaker, explore, analyze, and process data, model training, model deployment, batch transform, validating models, model monitoring, ML frameworks, Python and R, and supported regions and quotas. In section 3, we'll conclude the course with the conclusion and go over a summary of what we learned throughout the course. So that in mind, thanks for watching. I'll see you inside the course. Welcome to section 2, where we're going to talk about Amazon SageMaker. So in this video, we're going to go over an overview of what we're going to be learning throughout this section. So first, we're going to learn about what is Amazon SageMaker. Then we're going to talk about machine learning with SageMaker, explore, analyze, and process data, model training, model deployment, batch transform, validating models, model monitoring, ML frameworks, Python and R, and then supported regions and quotas. So that in mind, thanks for watching. I'll see you in the next video. All right, welcome back. So in this video, we're going to talk about what is Amazon SageMaker, okay? So that's a great question. Amazon SageMaker is a fully managed machine learning service. With SageMaker, data scientists and developers can quickly and easily build and train machine learning models and then directly deploy them into production-ready hosted environments. It provides an integrated Jupyter authoring notebook instance for easy access to your data sources for exploration and analysis. So you don't have to manage servers. It also provides common machine learning algorithms that are optimized to run effectively against extreme large data in a distributed environment. With native support For bring your own algorithms and frameworks, Sagemaker offers flexible, distributed training options that adjust to your specific workflows. Deploy a model into a secure and scalable environment by launching it with a few clicks from Sagemaker Studio or the Sagemaker console. Training and hosting are billed by minutes of usage with no minimum fees and no upfront commitments. So basically, you can pay as you go, and it's not a big investment right away, right? Okay, so let's look at some of the features now of Amazon SageMaker. Now that we know what it is, let's look at the features. So Amazon SageMaker includes the following features. It has Amazon SageMaker Studio, an integrated machine learning environment where you can build, train, deploy, and analyze your models in the same application, okay? Amazon SageMaker Ground Truth, high-quality training data sets by using workers along with machine learning to create labeled data sets. Amazon Augmented AI, human-in-the-loop reviews. Okay. Amazon SageMaker Studio Notebooks, the next generation of SageMaker notebooks that includes SSO integration, fast startup times, and single-click sharing. Pre-processing, analyze and pre-process data, tackle feature engineering, and evaluate models. Amazon SageMaker Experiments. Experiment management and tracking. You can use the track data to reconstruct an experiment, incrementally build on experiments conducted by peers, and trace model lineage for compliance and audit verifications. Then we have the Amazon SageMaker Debugger. Inspect training parameters and data throughout the training process, automatically detect and alert users to commonly occurring errors as a parameter values getting too large or small. Amazon SageMaker Autopilot, users without machine learning knowledge can quickly build classification and regression models. Reinforcement learning, maximize the long-term reward that an agent receives as a result of its actions. Batch transform, pre-process data sets, run interference, when you don't need a persistent endpoint, and associate endpoint records with inferences to assist the interpretation of results. Amazon SageMaker Model monitor and analyze models in the production endpoints to detect data drift and deviations in model quality. Amazon SageMaker Neo, train machine learning models once, then run anywhere in the cloud and at the edge. Amazon SageMaker Elastic Interface, speed up the throughput and decrease the latency of getting real-time inferences. Okay. Amazon SageMaker Pricing. Are you a first-time user of Amazon SageMaker? We recommend that you do the following. Read how Amazon SageMaker works. Set up Amazon SageMaker. Okay. Amazon SageMaker Autopilot simplifies machine learning experience by automating machine learning tasks. Okay. So let's keep going down here. So that in a nutshell is what Amazon SageMaker is. Okay. And again, we're going to continue on and learn more about this in the upcoming videos. So thanks for watching. I'll see you in the next video. All right, welcome back. So in this video, we're going to talk about machine learning with Amazon SageMaker. So this section describes a typical machine learning workflow and summarizes how to accomplish those tasks with Amazon SageMaker. You can see I'm having a little difficulty today, you know. Take it easy on me, okay? So in machine learning, you teach a computer to make predictions or inferences. First, you use an algorithm and example data to train a model. Then you integrate your model into your application to generate interfaces in real time and at scale. In production environment, a model typically learns from millions of example data items and produces inferences in hundreds to less than 20 milliseconds. So basically what you're going to do is you're going to teach the computer what you want it to do and then execute that. Okay. And so that's what this is all about, is we're going to train a model. So let's look at the diagram here real quick. So you train a model, evaluate the model, then deploy the model. So deploy to production, monitor, collect data, and then fetch, clean, and prepare. Okay, and that's kind of the life cycle of the Amazon SageMaker. Is you're going to send data to the computer, you're going to teach the computer, and then you're going to go from there. Okay, and that's really the idea, is you want to do that. And then we're going to do something else here. We're going to go more in detail here. So we're going to generate an example data, fetch the data, clean the data, prepare to transform the data, then train a model. Training the model. To train a model, you need an algorithm. The algorithm you choose depends on a number of factors. Okay, evaluating the model, and then deploy the model. Okay, so machine learning is a continuous cycle. After deploying a model, you monitor the interferences, collect ground truth, and evaluate the model to identify drift. You then increase the accuracy of your inferences by updating your training data to include the newly collected ground truth. You do this by retraining the model with the new data set. Okay, so thanks for watching. I'll see you in the next video. All right, welcome back. So in this video, we're going to talk about explore, analyze, and process data. So before using a data set to train a model, data scientists typically explore, analyze, and pre-process it. For example, in one of the exercises in this guide, you use the MNIST data set, a commonly available data set of handwritten numbers for model training. Before you begin training, you transform the data into a format that is more efficient for training. Okay, so to pre-process data, use one of the following methods. Use a Jupyter notebook on Amazon SageMaker notebook instance. You can also use the notebook instance to do the following. Write code to create a model training jobs, deploy models to SageMaker hosting, test or validate your models. You can use a model to transform data by using SageMaker's batch transform. Okay, Amazon SageMaker processing enables running jobs to pre-process and post-process data, perform feature engineering, and evaluate models on SageMaker easily and at scale. When combined with the other critical machine learning tasks provided by SageMaker, such as training and hosting, processing provides you with the benefit of a fully managed machine learning environment, including all the security and compliance support built into SageMaker. With processing, you can have the flexibility to use the built-in data processing containers or to bring your own containers and submit custom jobs to run on managed infrastructure. After you submit a job, SageMaker launches the compute instances, process and analyzes the input data, and releases the resources upon completion. Okay, so thanks for watching. I'll see you in the next video. All right, welcome back. So in this video, we're going to talk about how to train a model with Amazon SageMaker. So the following diagram shows you how to train and deploy a model with Amazon SageMaker. So if we just look at the diagram and we start from Amazon SageMaker, you can see that we have training code, which goes to model artifacts, which goes to the S3 bucket, which goes to the deployment hosting. So the helper code, the interfere code, and then the endpoint, and then the client application. And then it goes back and does it again. And it goes through this whole process of going from the endpoint to the ground truth to the training data to the model training to the model artifacts to deployment to the endpoint. And it just keeps doing that over and over again and never stops doing that, because that really is the life cycle of artificial intelligence or computer training with SageMaker. Okay, so let's look at the next item now. Okay, and that's going to be, let's scroll down here. Let's look at the next model here. Okay, the next diagram, I should say, which is zoomed in on, right? So before we do that, so the area labeled SageMaker highlights the two components of SageMaker, model training and model deployment. Okay, so those are really the two big ones in SageMaker, is the model training. So let me go back to this one, and then I'll go down here real quick and talk about model training and deployment. So the model training where you're training the computer a certain instance. You're given an instance to teach it what you need it to do so that it can do that process for you. And then it can analyze, millions of tables and data in milliseconds because it can process it quicker with the helper code and then the training code. Okay. And then it'll run it. So the S3 bucket training data goes to the helper code. The helper code goes to the training code, which is the model training. And then the trainer code image is from the EC2 container registry. That goes here too. And then it goes to the S3 bucket, which is the model artifacts. And then if we go back up to this diagram again, okay, it goes to the deployment and hosting. So it has the helper code, the interfere code, and then the interfere code image, and then it connects with the endpoint. And then the endpoint goes to the client application. So that's when it makes a request, and then it sends it back, and then sends the request there. So it's going back and forth here. So that's really how you do model training. So thanks for watching. I'll see you in the next video. All right, welcome back. So in this video, we're going to talk about how to deploy a model in Amazon Sagemaker. So after you train your model, you can deploy it using Amazon Sagemaker to get predictions in any of the following ways. To set up a persistent endpoint to get one prediction at a time, use Sagemaker hosting services. To get predictions for an entire data set, use Sagemaker batch transform. Okay, so deploy a model on Sagemaker hosting services, for example, of how to deploy a model to Sagemaker services. See step 6.1, deploy the model to Sagemaker hosting services. Okay, or if you prefer, watch the following video tutorial. Okay, now we're going to talk about the diagram here. So Sagemaker provides model hosting services for model deployment as shown in the following diagram. Sagemaker provides an HTTPS endpoint where your machine learning model is available to provide interferences. Okay, so again, this is what we talked about in the previous video, and it was this exact diagram that we were talking about, and we're just going to go over it again. The training data, okay, you send that from the S3 bucket to the model training, right? So this is the model training, and you create the helper code and then the training code, and then EC2 container has the training code image, and that sends it here, and then it goes up here to the model artifacts, and it's the S3 bucket, which goes to the deployment, then hosting, and then the interface code image and the interface code work together, and it goes to the endpoint, which goes to the client, and the client brings it back to the endpoint, which goes back to deployment and grabs the data. And then when it's done, it does a loop. And then it goes through this whole loop again, okay, this whole process. Okay, best practices for deploying models on Sagemaker hosting services. When hosting models using Sagemaker hosting services, consider the following. Typically, a client application sends requests to Sagemaker HTTPS endpoint to obtain interferences for deployed model. You can also send requests to the endpoint from a Jupyter notebook during testing. Okay. You can deploy a model trained with Sagemaker to your own deployment target. You can deploy multiple variants of models to the same Sagemaker HTTPS endpoint. You can configure a production variant to use application auto-scaling. And you can modify an endpoint without taking models that are already deployed into production or out of service. Changing or deleting model artifacts or changing interfere code after deploying model products produces unpredictable results. Okay. So again, those are the best practices for deploying models on Sagemaker hosting services and how to deploy a model in Amazon Sagemaker. So thanks for watching. I'll see you in the next video. All right, welcome back. So in this video, we're going to talk about batch transform. So get interferences for an entire data set with batch transform. So to get interferences for an entire data set, use batch transform. With the batch transform, you can create a batch transform job using a trained model and the data set, which must be stored in Amazon S3. Amazon Sagemaker saves the interferences in an S3 bucket that you can specify when you create the batch transform job. Batch transform manages all of the compute resources required to get inferences. This includes launching instances and deleting them after the batch transform job is completed. Batch transform manages interactions between the data and the model with an object within the instant node called an agent. Use batch transform when you want to get inferences for an entire data set and index them to serve inferences in real time. Don't need persistent endpoint that applications, for example, web or mobile apps, can call to get inferences. Don't need the sub-second latency that Sagemaker hosted endpoints provide. You can also use batch transform to pre-process your data before you're using it to train a new model or generate inferences. The following diagram shows the workflow of a batch transform job. So we have the record batch goes to the agent. It requests data to the model that transforms to here, and then it goes over to the results assembled data and then results in 3S bucket. Okay. To perform a batch transform, create a batch transform job using either the Sagemaker console or the API providing the following. The path to the S3 bucket where you have stored the data from that you want to transform, the compute resources that you want Sagemaker to use for the transform job. Compute resources are machine learning, ML, compute instances that are managed by Sagemaker. The path to the S3 bucket where you want to store the output of the job. The name of the Sagemaker model that you want to use to create inference. You must use a model that you have already created either with the create model operation or the console. The following is an example of what a dataset file might look like. An example of an input file, content, okay? Record one, attribute 1, record attribute 1, attribute 2, attribute 3, and then record one, attribute M, okay? A record is a single input data unit. So there you go. So that is get interferences for an entire data set with batch transform. So thanks for watching. I'll see you in the next video. All right, welcome back. So in this video, we're going to talk about validate a machine learning model. So after training a model, evaluate it to determine whether its performance and accuracy enable you to achieve your business goals. You might generate multiple models using different methods and evaluate each. For example, you could apply different business rules for each model and then apply various measures to determine each model's sustainability. You might consider whether your model needs to be more sensitive than specific or vice versa. You can evaluate your model using historical data offline or live data. Offline testing, use historical not live data to send requests to the model for interferences. Deploy your trained model to an alpha endpoint and use historical data to send interference requests to it. To send the requests, use a Jupyter notebook in your Amazon Sagemaker notebook instance and either the AWS SDK for Python, Bodo, or high-level Python library provided by Sagemaker. Online testing with live data. Sagemaker supports A/B testing for models in production by using production variants. Production variants are models that use the same interference code and are deployed on the same Sagemaker endpoint. You configure the production variants so that little portion of the live traffic goes to the model that you want to validate. For example, you might choose to send 10% of the traffic to a model variant for evaluation. After you are satisfied with the model's performance, you can route 100% traffic to the updated model. For an example of testing models in production, see test models in production. For more information, see articles and books about how to evaluate models, for example, evaluating machine learning models. Options for offline model evaluation include validating using a holdout set. Machine learning practitioners often set aside a part of the data as holdout set. They don't use this data for model training. With this approach, you evaluate how well your model provides inferences on the holdout set. You can assess how effectively the model generalizes what it learned in the initial training, as opposed to using model memory. This approach to validation gives you an idea of how often the model is able to infer the correct answer. In some ways, this approach is similar to teaching elementary school students. First, you provide them with a set of examples to learn, then test their ability to generalize from their learning. With homework and tests, you pose problems that were not included in the initial learning and determine whether they are able to generalize effectively. Students with perfect memories could memorize the problems instead of learning the rules. Typically, the holdout data set is about 20 to 30% of training data. K-fold validation. In this validation approach, you split the example data set in K parts. You treat each of these parts as holdout set for K training runs and use the other K1 parts as the training set for that run. You produce K models using a similar process and aggregate the models to generate your final model. The value K is typically in the range of 5 to 10. So that is validating models. So thanks for watching. I'll see you in the next video. All right, welcome back. So in this video, we're going to talk about model monitoring. So monitoring a model in production. So after you deploy a model into your production environment, use Amazon SageMaker Model Monitor to continuously monitor the quality of your machine learning models in real time. Amazon CloudWatch Model Monitor enables you to set up an automated alert triggering system when there are deviations in the model quality, such as data drift and anomalies. Amazon CloudWatch logs collects log files of monitoring the model status and notifies when the quality of your model hits certain thresholds that you preset. AWS CloudTrail stores the log files to an Amazon S3 bucket you specify. Early and proactive detection of model deviations through AWS Model Monitor products enables you to take prompt actions to maintain and improve the quality of your deployed model. Okay? So that's model monitoring. So thanks for watching. I'll see you in the next video. Hello everyone and welcome back to ML frameworks, Python, and R. So in this video, we're going to cover all of these topics here. So Apache, MXNet, Apache Spark, Chainer, PyTorch, scikit-learn, Spark ML Serving, and TensorFlow. Okay, so let's talk about how to use machine learning frameworks, Python and R, with Amazon SageMaker. So you can use Python and R natively in Amazon SageMaker notebook kernels. There are also kernels that support specific frameworks. A very popular way to get started with SageMaker is to use the Amazon SageMaker Python SDK. It provides open source Python APIs and containers that make it easy to train and deploy models in SageMaker, as well as examples for use with several different machine learning and deep learning frameworks. For information about using specific frameworks or how to use R in SageMaker, see the following topics. So languages, SDK, and user guide. So Amazon SageMaker Python SDK, R, API reference guide for Amazon SageMaker, and then machine learning and deep learning framework guides. So these are the ones that we're going to be talking about in depth. We're going to go over all the documentation and go over a summary of what they're talking about in each one. So we're going to talk about Apache MXNet. We're going to talk about Apache Spark. We're going to talk about Chainer, PyTorch, scikit-learn, Spark ML Serving, and TensorFlow. So let's go look at Apache MXNet. Okay. So you can use SageMaker to train and deploy a model using custom MXNet code, the Amazon SageMaker Python SDK, MXNet estimators and models, and the SageMaker open source MXNet container make writing a MXNet script and running it in SageMaker easier. What do you want to do? I want to train a custom MXNet model in SageMaker. For example, Jupyter Notebook, see the MXNet example notebooks in the Amazon SageMaker examples GitHub repository. Okay. For documentation, see train a model with MXNet. I have an MXNet model that I trained in SageMaker and want to deploy it to a hosted endpoint. Okay. I have an MXNet model that I trained outside of SageMaker and want to deploy it to SageMaker endpoint. So what they're doing is they're giving you documentation for each one of these examples that you want to do, okay? Now, what we're going to do is when we come back and do a project about the documentation that we've been covering in this course, we're going to come back and talk about each one of these in more detail. But right now what we're doing, and I've said this before, is we are just coming in and basically summarizing what they're talking about so that you get a basic understanding of what's going on. And then I come back and we do a more advanced dive into the information. Okay. That's really the idea, is to kind of ease you into it instead of just going right to the advanced stuff. And you're like, okay, I don't even have any idea what he's talking about. So in this way, at least we're learning the terminology and we're talking about it and understanding what we're doing here. So I want to see the API documentation for Amazon SageMaker Python SDK, MXNet classes. So for more information, see MXNet classes. I want to find SageMaker MXNet container repository. Okay. And I want to find information about MXNet versions supported by AWS deep learning containers. So for more information, see available deep learning container images. Okay, and then for general information about writing MXNet script mode training scripts and using MXNet script estimators and models with SageMaker, see using MXNet with SageMaker Python SDK. Okay, so that is how to use Apache MXNet with Amazon SageMaker. Now what we're going to do is we're going to talk about Apache Spark. So I'm going to click on this one. And it's going to give me a whole bunch of options here, but we're going to talk first about Apache Spark with Amazon SageMaker. Okay, so this section provides information for developers who want to use Apache Spark for pre-processing data and Amazon SageMaker for model training and hosting. Okay, so for more information about supported versions of Apache Spark, see the Getting SageMaker Spark page in the SageMaker Spark GitHub repository. Okay. SageMaker provides an Apache Spark library in both Python and Scala that you can use to easily train models in SageMaker using org.apache.spark.sql.dataframe. Data frames in your Spark clusters. After model training, you can also host the model using SageMaker hosting services. So the SageMaker Spark library, com.amazon.aws.services.sagemaker.spark.sparks.dk provides the following classes among others. SageMaker Estimator extends the org.apache.spark.ml.estimator interface. You can use this estimator for model training in SageMaker. K-means SageMaker Estimator, PCA SageMaker Estimator, and XG Boost SageMaker Estimator extend the SageMaker Estimator class. So SageMaker model extends the org.apache.spark.ml.model class. You can use the SageMaker model for model hosting and obtaining inferences in SageMaker. Okay, so to download the SageMaker Spark library, you have the following options for downloading the Spark library provided by SageMaker. You can download the source code for both Python or PySpark and Scala libraries from SageMaker Spark GitHub repository. For Python Spark library, you have the following additional options. Use pip install SageMaker PySpark. In a notebook instance, create a new notebook that uses either Spark Magic, PySpark, or Spark, or the Spark Magic, PySpark 3 kernel, and connect to a remote Amazon EMR cluster. Okay, you can get the Scala library from Maven. Add the Spark library to your project by adding the following dependency to your pom.xml file. Okay, and that's right here. Integrate your Apache Spark application with SageMaker. The following high-level summary of the steps for integrating your Apache Spark application with SageMaker. So continue data pre-processing using the Apache Spark library that you are familiar with. Your data set remains a data frame in your Spark cluster. Load your data into a data frame and pre-process it so that you have a features column with org.apache.spark.ml.lina.lg.vector, okay, or of doubles, and an optional label column with values of double type. Use the estimator in the SageMaker Spark library to train your model. For example, if you choose the k-means algorithm provided by SageMaker for model training, you call the k-means Sagemaker estimator.fit method. Provide your data frame as input. The estimator returns a Sagemaker model object. The fit method does the following: converts the input data frame to the protobuf format by selecting features and label columns from the input data frame and uploading the protobuf data to Amazon S3 bucket. The protobuf format is efficient for model training in Sagemaker. Starts model training in Sagemaker by sending a Sagemaker create training job request. After model training has completed, Sagemaker saves the model artifacts to a S3 bucket. Sagemaker assumes that the IM role that you specified for model training to perform tasks on your behalf. For example, it uses the role to read training data from an S3 bucket and to write model artifacts to a bucket. Creates and returns a Sagemaker model object. The constructor does the following tasks which are related to deploying your model to Sagemaker. So it sends a create model request to Sagemaker, sends a create endpoint config request to Sagemaker, and sends a create endpoint request to Sagemaker, which launches the specified resources and hosts the model on them. You can get interferences from your model hosted in Sagemaker with the Sagemaker model.transform. Provide an input data frame with features as input. The transform method transforms it to the data frame containing interferences. Internally, the transform method sends a request to the invoke endpoint Sagemaker API to get inferences. The transform method appends the inferences to the input data frame. Okay, so that's how you work with how to use Spark, Apache Spark with Amazon Sagemaker. Now let's look at Sagemaker with Apache Spark, their example. Okay, so let's just I'm gonna go over this briefly and just talk about what they're doing here. So Amazon Sagemaker provides, and here's the topics too, because I'm kind of skipping around. I apologize for that. The topics here is use custom algorithms for model training and hosting on Amazon Sagemaker with Apache Spark. So what they're saying here is you're going to use custom algorithms for model training. So you're going to teach your computer, you're going to write training models for the computer to run so that it can understand what you're doing and then run tasks for you. And you're going to run it hosting it on Sagemaker with Apache Spark. Okay. Then the other one is use Sagemaker estimator in a Spark pipeline. Okay. So Amazon Sagemaker provides an Apache Spark library in both Python and Scala that you can use to integrate your Apache Spark applications with Sagemaker. For example, you might use Apache Spark for data preprocessing and Sagemaker for model training and hosting. Okay, so for more information, you can look here. This section provides example code that uses the Apache Spark Scala library provided by Sagemaker to train a model in Sagemaker using data frames in your Spark cluster. The example also hosts the resulting model artifacts using Sagemaker hosting services. Specifically, this example does the following. Uses the k-means Sagemaker estimator to fit or train a model on data. Because the example uses the k-means algorithm provided by Sagemaker to train a model, you use the k-means Sagemaker estimator. You train the model using images of handwritten single-digit numbers from the MNIST dataset. You provide the images as an input data frame. For your convenience, Sagemaker provides this dataset in an S3 bucket. In response, the estimator returns a Sagemaker model object, obtains inferences using the trained Sagemaker model. To get inferences from a model hosted in Sagemaker, you can call the Sagemaker model. Transform method, you pass a data frame as input. The method transforms the input data frame to another data frame containing inferences obtained from the model. Okay? For a given input image of handwritten single-digit number, the inference identities a cluster that the image belongs to. Okay. For more information, see k-means algorithm. This is the example code. Okay. So this is what they were referring to. The code does the following: loads the MNIST dataset from an S3 bucket provided by Sagemaker, AWS AI Sparks DK-dataset into a Spark data frame, MNIS training data frame, okay? And then the show method displays the first 20 rows in the data frame. Okay, so this is the first 20 rows. Okay, in each row, the label column identifies the image label. For example, if the image of the handwritten number is the digit 5, the label's value is 5. Okay, the features column stores a vector, org.apache.spark.ml.linalg.vector of double values. These are 784 features of handwritten number. Each handwritten number is a 28 by 28 pixel image, making 784 features. Creates a SageMaker estimator, so k-means SageMaker estimator. The fit method of this estimator uses the k-means algorithm provided by SageMaker to train models using an input data frame. In response, it returns a SageMaker model object that you can use to get inferences. Okay, the constructor parameters provide information that is used for training a model and deploying it on SageMaker. So training instance type and training instance count identify the type and number of ML compute instances to use for model training. Endpoint instance type identifies the ML compute instance type to use when hosting the model in SageMaker. By default, one ML compute instance is assumed. Endpoint initial instance count identifies the number of ML compute instances initially backing the endpoint hosting the model in SageMaker. SageMaker role. SageMaker assumes that this IAM role to perform tasks on your behalf. For example, for model training, it reads data from S3 and writes training results, model artifacts to S3. Okay. After the k-means SageMaker estimator object has been created, you set the following parameters are used in model training. The number of clusters that k-means algorithm should create during model training, you specify 10 clusters, one for each digit 0 through 9. Identifies that each input image has 784 features. Each handwritten number is 28 by 28 pixel image, making 784 features. Calls the estimator fit method. You pass the input data frame as a parameter. The model does all the work of training the model and deploying it to SageMaker. In response, you get a SageMaker model object which you can use to get inferences from your model deployed in SageMaker. You provide only the input data frame. You don't need to specify the registry path to the k-means algorithm used for model training because the k-means SageMaker estimator knows it. Calls the SageMaker model.transform method to get inferences from the model deployed in SageMaker. The transform method takes a data frame as input, transforms it, and returns another data frame containing inferences obtained from the model. Okay, for simplicity, we use the same data frame as input to the transform method that we used for model training in this example. The transform method does the following. Serializes the feature column in the input data frame to protobuf and sends it to the SageMaker endpoint for inference. Deserializes the protobuf response into the two additional columns, distance to cluster and closest cluster, in the transform data frame. The show method gets inferences to the first 20 rows in the input data frame. Okay? You can interpret the data as follows. A handwritten number with the label 5 belongs to cluster 4, closest cluster. A handwritten number with the label 0 belongs to cluster 5. A handwritten number with the label 4 belongs to cluster 9, and a handwritten number with the label 1 belongs to cluster 6. Okay, so now let's look at the custom algorithms for model training and hosting on Amazon SageMaker with Apache Spark. So in example 1, use Amazon SageMaker for training and inference with Apache Spark. You use the k-means SageMaker estimator because the example uses the k-means algorithm provided by Amazon SageMaker for model training. You might choose to use your own custom algorithm for model training instead. Assuming that you have already created a Docker image, you can create your own SageMaker estimator and specify the Amazon Elastic Container Registry path for your custom image. The following example shows how to create k-means SageMaker estimator from the SageMaker estimator. In the new estimator, you explicitly specify the Docker registry path to your training inference code images. Okay. In the code, the parameter in the SageMaker estimator constructor include training image. So you see it right here, identifies the Docker registry path to the training image contained in your custom code. Model image identifies the Docker registry path to the image containing inferior code. Request row serializer implements com.amazonaws.services.sagemaker.spark sdk.transformation.request row serializer. This parameter serializes rows in the input data frame to send them to the model hosted in SageMaker to Inference. Response row deserializer implements com.amazonaws.services.sagemaker.spark.sdk.transformation.response row deserializer. This parameter deserializes responses from the model hosted in SageMaker back into a data frame. Training Spark data format specifies the data format that Spark uses when uploading training data from a data frame to S3. For example, SageMaker for protobuf format, CSV, for comma-separated values, and libsvm for libsvm format. You can implement your own request row serializer and response row deserializer to serialize and deserialize rows from a data format that your inference code supports, such as .libsvm or .csv. Okay? So now let's talk about use the SageMaker estimator in Spark pipeline. Okay? So you can use org.apache.spark.ml estimators and org.apache.spark.ml.models and SageMaker estimators and SageMaker models and org.apache.spark.ml.pipeline pipelines as shown in the following example. Okay. The parameter training Spark data format options configure Spark to serialize protobuf the projected features column for model training. Additionally, Spark serializes to protobuf the label column by default. Because we want to make the inferences use the projected features column, we pass the column name and the protobuf request row serializer. Okay, so the following example shows a transform data frame. Okay, now let's talk about additional examples. So with this one, additional examples use Amazon SageMaker with Apache Spark. Now, additional examples of using Amazon SageMaker with Apache Spark are available on GitHub at github.com, AWS, SageMaker Spark, tree master examples. Okay, so that is how you use Apache Spark. Okay, now we're going to talk about Chainer. Okay, so Chainer, use Chainer with Amazon SageMaker. Okay, so you can use SageMaker to train and deploy a model using custom Chainer code. The SageMaker Python SDK Chainer estimators and models and the SageMaker open source Chainer container, making writing a Chainer script and running it in SageMaker easier. What do you want to know? What do you want to do? Okay, so they're going to ask the question and then give you links to the answer. Okay, and we're not going to go to the answer. We're just going to ask the question. And I'm going to leave you hanging, and then we're going to come back later and answer the question. Okay, I want you to think about it. So I want to train a custom Chainer model in SageMaker. Okay, so for a sample, Jupyter Notebook, see this example. Okay, in the GitHub repository. For documentation, go here. I have a Chainer model that I trained in SageMaker, and I want to deploy it to a hosted endpoint. For more information, click here. I have a Chainer model that I trained outside of SageMaker, and I want to deploy it to a SageMaker endpoint. Okay, for more information, see to deploy endpoints from a model data. Okay, I want to see the API documentation for Amazon SageMaker Python SDK Chainer classes. For more information, see Chainer classes here. Okay. I want to find information about SageMaker Chainer containers. For more information, see the SageMaker Chainer container GitHub repository. So that is Chainer with Amazon SageMaker. Okay. So thanks for watching with that. Now we're going to go on to PyTorch. So use PyTorch with Amazon SageMaker. Again, we're just going to ask questions and we're going to seek the answers later on in the course. Okay. So again, this is an introduction. So you can use Amazon SageMaker to train and deploy a model using custom PyTorch code. The SageMaker Python SDK, PyTorch estimators and models, and the SageMaker open source PyTorch container make writing a PyTorch script and running it in SageMaker easier. What do you want to do? I want to train a custom PyTorch model in SageMaker. The samples here, the documentation's there. I have a PyTorch model that I trained in SageMaker and I want to deploy it to a hosted endpoint. For more information, see the deploy PyTorch models. Okay. I have a PyTorch model that I trained outside of SageMaker. I want to deploy it to SageMaker endpoint. For more information, see deploy endpoints from model data. I want to see the API documentation for Amazon SageMaker Python SDK PyTorch classes. You can see the PyTorch classes here. I want to find the SageMaker PyTorch container repository. For more information, see the SageMaker PyTorch container GitHub repository. I want to find information about PyTorch versions supported by AWS deep learning containers. For more information, see available deep learning container images. So again, this is an overview of the documentation that you can go to if you want to seek these answers now. But what I recommend doing is waiting, because later in the course, we're going to come back and we're going to do a deep dive into this. Okay. So now let's talk about R. Okay. So R user guide to Amazon SageMaker. So this document will walk you through ways of leveraging Amazon SageMaker using R. This guide introduces SageMaker's built-in R kernel, how to get started with R on SageMaker, and finally several example notebooks. Okay. R kernel and SageMaker. So SageMaker notebook instances support R using a pre-installed R kernel. Also, the R kernel has the library and an R to Python interface. So you can use features of SageMaker Python SDK from within an R script. .pause is an optional library that you can add to your R kernel to get further functionality. Okay. So get started with R in SageMaker. So create a notebook instance using the t2.medium instance type and default storage size. You can pick a faster instance and more storage if you plan to continue using the instance for more advanced examples, or create a bigger instance later. Wait until the status of the notebook is in service and then click Open Jupyter. Create a new notebook with R kernel from the list of available environments. When the new notebook is created, you should see an R logo in the upper right-hand corner of the notebook environment and also R as the kernel under the logo. This indicates that SageMaker has successfully launched the R kernel from this notebook. You can see it right here. Alternatively, when you are in the Jupyter notebook, you can use the kernel menu, then select R from the change kernel option. Okay, so example notebooks. So again, we're going to come back later and look at this and do a deep dive on this. But they have getting started with R on SageMaker, beginner level, end-to-end machine learning with R on SageMaker, and SageMaker batch transform using R kernel, intermediate level, and then advanced level. And these are example notebooks. So again, when we come back to do projects, we're going to come back and do a deep dive into all that and really get into the nitty-gritty. Okay. So now let's go on to the next one here, and we're going to talk about scikit learn with Amazon SageMaker. Okay. So what do you want to do? I want to use scikit learn for data processing, feature engineering, or model evaluation in SageMaker. For documentation and examples, click on these links here. I want to train a custom scikit learn model in SageMaker. Samples here, documentation's there. I have a scikit learn model that I trained in SageMaker and want to deploy it in a hosted endpoint. For more information, you go right here. I have a scikit learn model that I trained outside of SageMaker and want to deploy it to SageMaker endpoint. For more information, see deploy endpoints from model data. I want to see the API documentation for Amazon SageMaker Python SDK, scikit learn classes. For more information, see the scikit learn classes. I want to see information about SageMaker scikit learn containers. For more information, see the SageMaker scikit learn container GitHub repository. All right, so now let's go to Spark ML serving, model and predictor, and the Amazon SageMaker open source Spark ML serving containers support deploying Apache Spark ML pipelines serialized with mleap and SageMaker to get inferences. Okay, so there's not a lot of information on this. There's more documentation than anything, but that's fine. Okay, now let's go on to the next one here. So then we have TensorFlow. Use TensorFlow with Amazon SageMaker. Okay, so you can use Amazon SageMaker to train and deploy a model using custom TensorFlow code. The SageMaker Python SDK TensorFlow estimators and models and the SageMaker open source TensorFlow containers make writing a TensorFlow script and running it in SageMaker easier. Use TensorFlow version 1.11 and later. For TensorFlow versions 1.11 and later, the Amazon SageMaker Python SDK supports script mode training scripts. What do you want to know? I want to train a custom TensorFlow model in SageMaker. So for the sample and the documentation, you go here. I have a TensorFlow model that I trained in SageMaker, and I want to deploy it to a hosted endpoint. For more information, we'd go here. I have a TensorFlow model that I trained outside of SageMaker and want to deploy it to SageMaker endpoint. For more information, see deploying directly from model artifacts. I want to see the API documentation for Amazon SageMaker Python SDK TensorFlow classes. For more information, see TensorFlow estimator. I want to find the SageMaker TensorFlow container repository. For more information, see the link here to get to the GitHub repository. I want to find the information about Tensor versions supported by AWS deep learning containers. For more information, see available deep learning container images. Okay, so use TensorFlow legacy mode for versions 1.11 and earlier. The Amazon SageMaker Python SDK provides a legacy mode that supports TensorFlow versions 1.11 and earlier. Use legacy mode TensorFlow training scripts to run TensorFlow jobs in SageMaker if you have an existing legacy mode scripts that you do not want to convert to script mode. You want to use TensorFlow version earlier than 1.11. Okay, for information about writing legacy mode TensorFlow scripts to use with SageMaker Python SDK, see TensorFlow SageMaker estimators and models. So with that, what we're going to do now is we're going to go over an overview of what we learned throughout the section, because this was a really long video, really long-winded video. Even for me, I'm out of breath here. No, I'm just kidding. So we talked about ML frameworks, Python and R. Okay, so let's just go over kind of this summary here. So languages, SDKs, and user guides. So if you want to get user guides for Amazon SageMaker Python SDK, you can go here. If you want to get a guide for R, go there. API reference guide for Amazon SageMaker, you would go here. Now, disclaimer again, I want to say that later in the course, we're going to come back and we're going to do a deep dive on all this information that we covered so that I don't just leave you hanging with, I'm reading text from a document. Okay. The idea of me going into the documentation and talking about it and reading it is so that you hear it and then you learn it over time. The more that we do this repetition of going into the documentation, you create a habit of, okay, if I have a question or if I don't know how to do something, I don't need to look at the course. I'm going to go figure it out myself. You need to become a problem solver when you're using Amazon SageMaker or any Amazon product. You need to be self-reliant, is what I'm trying to say. You need to go into the documentation and understand what they're saying and then be able to utilize that information to get the result that you're looking for. Okay? Then we have machine learning and deep learning framework guide. So Apache MXNet, Apache Spark, Chainer, PyTorch, scikit-learn, okay, Spark ML serving, and TensorFlow. So we went and did more of a deep dive on all these, and we learned a lot of information about what all these do in terms of machine learning and deep learning framework guides. Okay, so let me just click on them real quick so we can kind of see what we talked about and really just ask questions. And I just read the questions and I didn't answer any of the questions because we're going to do that later on. Okay, we're going to come back and answer all these questions. And that's going to be the fun part, is trying to figure out how to solve the problem of what these questions are presenting. And that's really the point of this course, is I want to, for the first hour, I just want to ask you questions. I don't want to give you any answers. And the reason why I'm doing that is then you're curious and you're like, okay, well, how do I do this and how do I do that? He's not talking about any of this. That's the point. I want to lead you into the answer and lead you into the examples so that I ask a question, then we learn how to do it, and then we find the answer. That's the point, okay? So then we talked about Apache Spark. We went over an example, additional examples. Then we talked about Chainer. We talked about PyTorch, R, scikit-learn, Spark ML serving, and then TensorFlow with Amazon SageMaker. So that in a nutshell is how to use machine learning frameworks, Python and R with Amazon SageMaker. So thank you so much for watching. I'll see you in the next video. All right, welcome back. So in this video, we're going to talk about supported regions and quotas. So let's jump right into that. And so for a list of AWS regions supported by Amazon SageMaker and the Amazon Elastic Compute Cloud, Amazon EC2 instance types that are available in each region, see Amazon SageMaker pricing. Okay. So each AWS region is divided into subregions known as availability zones. For a given region, the availability zones in that region don't always contain the same instances types supported by SageMaker. If an availability zone in the region contains a given instant type, that instant type is listed as available in that region. In the region, I should say. Not in that region, in the region. For a list of AWS regions supported by Amazon SageMaker Studio, see Amazon SageMaker Studio. Okay. Then we have for a list of SageMaker service endpoints for each region and the SageMaker service quotas for each instance type, see Amazon SageMaker endpoints and quotas. Okay. You can request a quota increase using service quotas for AWS Support Center. To request an increase, see AWS service quotas in the AWS General Reference. Supported instance type and availability zones. So this topic provides one table for each AWS region supported by Amazon SageMaker. Each table has a column for each availability zone in the region. For each availability zone, SageMaker components that support each instance type are shown. The components are listed in the tables as follows: notebook instances, training jobs, batch transform jobs, and endpoints, hosted endpoints. If no components support the instance type in availability zone, the cell contains none. If all the components support the instance type in availability zone, the cell contains all. Not all components are supported on each instance type in each availability zone. To create a component on a specific instance type, you must specify the availability zone ID, which is listed in the header row of each table. For example, use 1-AZ1. Okay. For more information, see regions and availability zones in the Amazon EC2 user guide and AZ IDs for your resources in the AWS RAM user guide. So here are the region tables. We have US, Ohio, US East, North Virginia, US West, North California, US West, Oregon, okay? Asia Pacific, Hong Kong, Asia Pacific, Mumbai, Asia Pacific, Seoul, Asia Pacific, Singapore, Asia Pacific, Sydney, Asia Pacific, Tokyo. Then we have Canada, which is central. We have Europe, Frankfurt, Ireland, London, Paris, and Stockholm in Europe. And then the Middle East, Bahrain. South America is Sao Paulo. AWS Government Cloud is US Government West. And then US ISO East, US ISO East. So those are all the regions available with Amazon SageMaker. Okay, so thanks for watching. I'll see you in the next video. Congratulations on finishing Amazon SageMaker. In this video, we're going to go over a summary of what we learned throughout the course. So in section 2, we talked about Amazon SageMaker. We talked about what is Amazon SageMaker, machine learning with SageMaker, explore, analyze, and process data, model training, how to do model deployment, how to do batch transform, validating models, model monitoring, ML frameworks, Python and R, and supported regions and quotas. So again, I want to thank you so much for watching Amazon SageMaker. If you have any questions or concerns about the course, please let me know. I'll be happy to help you in any way that I can. Until next time, thank you so much for watching and take care.